tints and colors of electrons in the superstition of Zizek. Okay, so these are some expressionistic concepts which attempt to get to the simple ground of some of the problems of the physics of the early 20th century, in the sense that if we look at Plato's dialogue called the Minos, named after the judge king Minos, we see the simple theoretical basis which attempts to say the things that are the most clear and sound about law, whereas in Plato's Nomoi, the subject matter of law is developed at length and in all the rich historical detail of ordinary life on the island of Crete, from which Minos supposedly hailed in legend, and where he met with Zeus in the cave at the foot of Mount Ida. So the grounding theory is supposed to be simpler than the way things play out in historical life, and it's supposed to go to those things which are eternal and which we can rely the most on. So one, I'm wondering if Zizek is redoubling the old superstition which he claims to be so much against in the case of COVID, for instance. He says that viruses are just stupid viruses and they have no meaning, which is obviously true in one sense, is that they don't really care about human beings, so to speak. That would be some kind of anthropological projection, like saying that a worm enjoys the lovely, or let's say a termite enjoys this lovely taste of the wood or something. It's only sort of by a stretch of metaphor that we can say that, because the termite doesn't really experience the notion of having a meal and enjoying a meal. Is he doing the exact same thing? But on the other hand, of course, COVID is very meaningful in the sense that it affects human beings, and anything that affects human beings is obviously meaningful. But is it a sign from the cosmos? That would be what Zizek would want to rule out. That it should be interpreted. There should be some oracles that will interpret COVID as a sign from the cosmos. But nonetheless, somebody has to say what's the meaning of COVID for human life. So in a way, it amounts to the same thing. But is he trying to bring a meaning to physics? This is what I think he is trying to do, is superstitiously bringing meaning to physics, where in fact the electron is just going its own shadowy way. It doesn't care about human beings. It's neither probabilistic or deterministic. There's absolutely no meaning in itself to those terms. I'll try to demonstrate that. And I think that's also behind this Hassenfelder notion of the determination that they mentioned in this recent Zizek John Carroll thing. And I think neither of them understood what she was saying. If we have a mathematical model with an operator called the spinor, S-P-I-N-O-R, which represents the electron, then we could say that it's probabilistic or it's not probabilistic, and we can do all kinds of things. We can plug it in to a mathematics which only has information about the vector, about what direction something's going, but how fast it's going, and then make it into an equation or the other side of the equation has some complex things going on, which then help us in making predictions. Because in ordinary life, so this is one of the ground issues, is in ordinary life, and also in Newton's physics, if you see something moving in a direction, you also know the position. You just look, and then you can kind of guess where it's going. But if you only had saying know that something's pointed in a certain way, and moving in a certain rate, but you don't know exactly where it is now, it's hard to guess. Like, say it's a car, you wouldn't say a situation where you couldn't guess whether you can safely cross the street or safely jaywalk in front of a car, because you don't actually know its position. It's sort of ink ille lacrimae, from here all these tears. That's why we need the matrix equations, for which I assume the movie is named. And the point being, because you leap into this these Schrodinger equations where you're blind in terms of all your ordinary ways of guessing how things will happen. And that's the whole point. But in the mathematics, it matters whether you do a probabilistic guess or whether you treat it as determined. But it doesn't matter to the electron. So this idea was developed on the other. So Hassenfelder kind of says this, and then she concludes it's all determined. And what she means is, say you had God, and then you had these things which the math models as random. From God's point of view, they're not random. He knows which order it's going to come in. It's only random from our point of view, because we're saying we have no way in to guess how the order is going to be. But you could say with equal justice, there's free will, because God has chosen to put it in this order. It's totally indifferent to the modeling of the spinner, or to the things themselves. I'm sorry, it's totally indifferent to the things themselves, whether they're from the human point of view, random, like 536, 12, 43, say some order of numbers that are unpredictable to the human. But from the point of view of the electron, it doesn't care that we don't understand which order it's coming in, right? And then you could create the notion of an intelligence that did understand this, in order to make it simple, to understand what we're saying. Maybe there's a super intelligence that kid predicted better. But it's indifferent whether you say this is a situation of free will or a situation of determination. It's just that from the side of view of attempting to predict, it matters, but it doesn't matter for the world itself. Doesn't care. It goes its own shadowy way. Or maybe it does care, right? But if it does care, then it's at a level of intelligence far beyond us, right? We don't understand it. So I think, how could we give a more clarity to this Zizek's pet idea of the ontological incompleteness with respect to the issue? So one, I want to say the beginning step of the problems in modern physics, when there were still physicists. So I don't think today there are physicists. It's is what I'm arguing. There's people that are kind of holding place who have copied, like apes, kind of copied what the real physicists were doing. But generally, they don't really understand what physics is. So like Sean Carroll is a great example of that. I think he considers real physics to be quote-unquote religion, which by, I guess, he means he doesn't know what metaphysics is, but that's what he kind of thinks. That's what the Catholics are doing, something called religion. Whereas I would say what they're doing is something called theology and metaphysics. And what that meant is clarifying basic concepts such as what a thing is, um, such as what causation is, such as what being is, um, uh, and consciousness, and other such basic things which we take for granted once we're already um, just trained monkeys who are just following steps. So like if somebody who has thought about all this stuff like Einstein or Heisenberg or Oppenheimer, etc., who understands these problems, or even the other guy, the Bohm, the more recent physicist, I think he's even still, David Bohm, who's still alive, I think, who are thinking about these questions, they can bring in something new, and then once it's created, everybody else can just ask, well, how do I proceed in doing this? And they can just get the picture version, like, oh, this is what you do, this is what you do, this is what you do, and just imitate it. And then they can hold that in place for decades and decades and decades until somebody that actually is a real physicist comes in and starts doing something new. And also they can expand on it. Like you have the, let's say, this order and progress notion. You have the periodic table, then you fill it out. You have some problems. You could go on for 20,000 years, 30,000 years in the same way of doing experimental science that was done in Newton's day in the Royal Society, right? And by the way, the first professional scientist, Robert Hooke, lived in Newton's day, worked for the Royal Society, and it makes one think a little bit of what Nietzsche says about, if it weren't entertaining, would they still be doing it? Of course, we had the Oppenheimer movie showing us how important the bomb was for great stupid activity, such as creating a bomb, such as destroying, such as wars. So in that sense, it would still be important, but would we care about having all these discussions, all the buzz? So, I mean, I forget what the source is, but Peter Brown, the historian, likes to quote this ancient text to show that in like the 4th or 5th century, ordinary people would kind of buzz about what was going on in the discussion between the Christian bishops and the councils, the Council of Nicaea and so on, the topics of the Trinity and stuff. There's gossip in the town squares about those, according to some ancient sources. So we have a lot of gossip about these physics topics today, but somehow these topics are considered interesting, aside from the actual military applications and other applications. Of course, we're told they're good for MRI machines or something. The first step, it seems to me, is in this experiment. What all Bohr was saying is, you get, is really what he's looking at is, for the first time, an experiment really cares about the historical, one-time, only existing object. So usually when you do an experiment, like you do an experiment on some substance, like I don't know, like that experiment with the that everybody does in school with the baking powder and vinegar or something like that, and you combine those two things, but you don't care about that it's this particular atom of baking soda, or that it's this particular droplet of vinegar. But for the first time, I think, in these experiments, which followed on the experiments done on with the vacuum tubes, where they isolated the electron, we had this problem where you did care about that exact object. You didn't. It wasn't only that you could run an experiment again and again on different, on a piece of metal, watch how it rusts. Get another piece of metal, watch how it rusts. See what this process is, calcification or whatever, or the building of calc or whatever, formation. But you really cared about that exact historical thing that only existed once. So it plugs us into this Hegelian issue of you have to write it down and say this is when it happens. So this is the only way you can get the exact time. And so the problem is, if you have an experiment, which is, as Bohr explained, it's similar to a photographic plate, where your information from the apparatus, from the Beobachter, which has this word Achtung in it, attention, from the thing that's supposed to be observing, at that specific moment where Hegel would tell you have to write it down to know when it happened, you get a specific reading, but only about either the position or the velocity. So like I just explained, from this basic ground, we don't have ordinary intuition anymore unless we have both those things. We can't, it's not enough information to guess at how something's going to happen. So then, on the notion, and so Oppenheimer brings in Piaget here. He says, on the notion that there's this ground before we learn how to basic intuition about how the world operates. There's this pre-ground, the pre-philosophic or pre-scientific ground, where we haven't yet decided our specific way of dealing with space, dealing with movement. I mean, physics is only concentrated on movement. That's the essence of physics, movement. A specific theory of what movement is, which is generally expressed as gravity. And then by extension, the electromagnetic forces. So the issue is, we have to focus on something that's just once, just this time. And that's the first time that's ever happened, and that science really cared that it had to deal with the historical objects, like you yourself are a being that will only exist once and never exist again. So in the same way, they had to treat the electron as something unique, and they can't rely on the statistics because the differences are too great. So even if you can get a bell curve or whatever, it's not sufficient for a specific experiment. Without both those measures, you can't get this specific experiment. And then they tried to find out ways to get around it. And the way to get around it is, I think it's in a way best expressed by, again, bringing out this von Neumann quote that nobody ever understands math, but you get used to it. So you get used to how to deal with the spinner a little bit, and then you can make your predictions better, and then you can tweak it. And it's a matter of getting used to the mathematics. But then what does this have to do with Zizek's pet idea of the ontological incompleteness? I find it hard to see any way to enter into that. So they try to push us to enter into that by saying that, okay, because the predictions have been more successful, it shows that there must be something to this way of conceiving of the matter. Well, let's try imagining it from the point of view of, is it that... So we could imagine that we could really see the moment when... I guess you can see it. So if you go in very close to the electron, there's the electron cloud, and you can actually see it with I guess, the generations of electron microscopes, which Schrodinger suggested. But this gets into another problem of the interference issue or the perturbance issue, because the electron microscope actually works by like bouncing an electron off stuff. So it's obviously involved in the experiment, and then that means whatever you're doing when you're observing is also, it's not what the things would be like on their own. It's only what it's like when we're there, pushing this stuff, bouncing off it, messing with it. So that's an issue of but it's still just it's not an issue of consciousness or anything like that. It's just the issue of very small physical interactions. The issue of consciousness, I think, so far as some of these guys reflect on it, comes in more because of the notion that you link to the questions that Kant asked about the conditions of any possible experience, these kind of notions that are studied subsequently by people like Piaget and by people like the Soviet psychologist, which suggested the zone of proximal development theory, because he said against Piaget, he said that it often does happen that people don't go through these stages, like Piaget said. They miss some of them, or they do it differently, and they have some different idea of how to operate. So it's like it often seems to one that people from different countries, different cultures, think somewhat differently, and even spatially, so even in a total way. So then it suggests that there's some pre-philosophic, pre-conceptual, so instead of having concepts by which we think clearly, there could be a time before these have developed, and then they could develop in all kinds of different ways. That's a great subject matter of anthropology, of many fields of study. But I don't know. I tried to see if there's any sense to it, but I just don't see how experiment can really bring us into that. I don't see where the experiments tell us anything about that. I don't see, I mean, if somebody knows, maybe they could tell me, but I don't see anywhere where there's any connection between the human being being involved, rather than the apparatus being involved, and the so-called collapse of the superposition. It only has to, this is not even something that's, so far as I understand it, this is not even something that's been observed in any way. It's only a mathematical concept. We could speculate about it really existing and then try to find it. So I understand some people have tried to do that, but they haven't done it. But that has to do with the apparatus physically interacting with the system. It doesn't really have anything to do with the quote-unquote consciousness. Although consciousness, but we could, I just think if we want to reflect on consciousness, we can do that in better ways than on the subject matter of physical experiment, which is a boring unconscious thing. That's something that goes on in clockwork. It's a boring clockwork material system. It doesn't actually have anything that much to do with human beings. The clock can go on by itself. It doesn't care if the human being is there. Okay, so just some reflections, and maybe it would be helpful if somebody could point out which direction we should probe in. And I'll continue to try to go over more of this material to see if there's any greater clarification to be got. But on the whole, my main remark is almost everything today we hear about physics is Pretty stupid and pretty uninteresting. It's only interesting to the extent that you hear about what experiments are going on, but there's no real insight into how it works. And the border concept seems to be that let's not think, but only, as von Neumann said, just get used to how the math operates. And that's all they're doing. They're not trying. There's no real attempt at, in any serious way, to understand it. The Einstein question. It's a grounding question. I don't think it makes even any sense what Zizek is trying to say, because if there were a point where you were looking at the electron cloud, which there is actually, and you see it start to disappear, what does that mean? It doesn't help us in any way. It only says that as a matter of datum, we have something random coming out before us, which appears to us random. But what does random mean? It just means we're not used to it, so we can't easily predict it the way we can predict whether we can cross the street in front of a coming car. If we were used to it, then we would say, "Oh, it's not random. I get it. That's how it happens." The question of the ontological incompleteness is supposed to, according to Zizek, signal the freedom of the universe itself somehow, but I think that's unnecessary, again, because what Ossenfelder is saying is basically that what's ever happening with the hule, or the material of the body, it's the same at the small scale as it is at the big scale. But that doesn't mean anything, because whatever free will is, it could be. This is best tackled by this discussion between Skinner and the Irish Catholic on the episode of The Firing Line, the Bill Buckley show, where he says this is a matter of nothing but ism. So what if in physical terms it's all like clockwork? You don't know the ultimate source of the causation. You don't know why the body as a whole is moving. You only know, you can kind of predict, or you can't predict totally how it moves. Okay, well, say we could predict totally, but then I think that would lead to this stupid problem in the Philip K. Dick book about if you can predict that a ball is going to fall, then you can also interfere with it and catch it. It would just create pockets of determinacy which you could then interfere with. Okay, so I have to think more about it, but I just don't. But okay, let's leave it at that.